Hey, thanks for having me today at the Semaphore conference. I'm Sneha Wadhwa, a senior software engineer at Confluent, part of CP Build and Release team. I'm going to talk a little bit about what we do at Confluent and focus mostly on our SemaphoreCI migration journey. Here's a quick agenda. I'll start by providing some organizational context, a brief introduction of what we do at Confluent. Then I'll take you through our journey of migrating the Confluent platform's build, package, and release pipelines from Jenkins to Semaphore. We'll dive into the key design choices that shaped this transition, the challenges we encountered, and how we tackled them. Most importantly, we'll look at the impact this migration has had on our overall processes. And then finally, I'll wrap up. So here we go. Confluent is a leader in building data streaming platform and is on a mission to set every company's data in motion. It was founded by the creators of Apache Kafka, which is an open source technology that has really become the industry standard for real time data streaming. In fact, it's used by more than 75% of Fortune 500 companies. So, what does Confluent actually do? Confluent serves as the backbone, or you can think of it as a central nervous system for organizations, enabling seamless, continuous flow of data across systems. Now, what does this really mean? It means that businesses are no longer stuck with traditional batch processing, where they have to wait for data to be collected, processed, and acted upon. Instead, with Confluent, they can access, process, and react to information in real time as it happens. And that's a game changer. It allows companies to make faster, smarter, and data driven decisions. So, whether it's detecting fraud instantly, or powering real time analytics, or enabling seamless event driven architectures, Confluent provides the real time data infrastructure and platform. While Apache Kafka provides a powerful foundation for real time data streaming, but Confluent goes above and beyond by offering a fully managed enterprise grade platform, making it easier for businesses to harness the power of data streaming without the complexity of managing infrastructure. Now, when it comes to deployment, organizations have two choices. If they prefer cloud native experience, Confluent Cloud delivers a fully managed serverless Kafka solution, taking care of all the operational overhead. So teams can focus on building the software rather than maintaining infrastructure. Whereas for organizations that need more control and customizations, Confluent offers Confluent Platform, which is designed for self-managed environments. It provides advanced tools for security, monitoring, governance, and stream processing, making it ideal for enterprises that want to run Kafka on their own infrastructure. Confluent provide features like KSQL DB for stream processing, schema registry for data consistency. Then there's tiered storage for cost efficient scalability. And of course, security being a big concern for any enterprise. Confluent offers enterprise grade security with features like role based access control, ensuring organizations can securely stream data at scale. So at the end of the day, whether you need a fully managed cloud native experience or a self-managed solution with full control, Confluent gives you the best of both worlds. So you can focus on building real-time applications instead of worrying about infrastructure. Yeah, so if you haven't already, I would encourage you to visit our website to know more about Confluent offerings and solutions. And you can get started, try out CP and Confluent Cloud for free. Uh, Yeah, now let's talk about our semaphore migration journey. First of all, why did we migrate? Confluent has been using Semaphore for a few years now. Most of our Confluent Cloud workloads were already running on Semaphore. So we decided to migrate everything to a single unified CI system. The goal was to reduce maintenance work and improve the developer experience by having everything under one roof. Ultimately, we wanted a unified CI/CD platform for the entire company. No more managing multiple systems or dealing with complexities of having different tools across different teams. Yeah, now let's talk about the workflows we migrated. Last year, we focused on migrating our CP packaging and release pipelines. To give you a brief overview of what CP packaging involves, at a very high level, we build and package Confluent platform, CP, components, and then release them to our customers for on-prem deployments. But this isn't a simple process. It's actually pretty complex and involves more than 35 to 40 different pieces coming together. And since we are always working to keep our offerings up to date and competitive, we release frequently. These releases come in various forms, including major releases that happen annually, minor releases, they go mid-yearly, then we have patch releases which go every quarter, and of course, other monthly and hotfix releases as needed. Now, this migration itself wasn't an easy or simple task, especially given the size and complexity of our workflows. It took a lot of effort, careful planning, and coordination across teams. But in the end, it has finally paid off, making our processes more efficient and scalable. Next, we'll dive into the design principles that guided us through this migration. But before we get there, let's unbox CP packaging and take a closer look at its deliverables and the different packaging types we offer. So, Confluent Platform is distributed in multiple forms. We have tarball archives that work with any operating system, making it platform agnostic. Then we have RPM and Debian packages for various Linux distributions, jar libraries for integration with Java-based systems, and we have Docker container images for those who prefer containerized deployments. All of these packages are available at packages.confluent.io, and the Docker images are published onto the Confluenting Docker Hub. Now, when it comes to our customers, they have a couple of options. They can either get the complete all-in-one CP package, which includes entire Confluent platform, or they can pick and choose one or more individual components like KSQL, schema registry, to plug and play into their existing Kafka clusters. So whether they are looking for a solution or just specific components, we've got them covered. Yeah, while migrating our CP pipelines to Semaphore, we took this opportunity to revamp the design of our CP build and release workflows, rather than just doing a plain lift and shift from Jenkins to Semaphore. In the next few slides, I'll take you through some of the key design principles that we applied and relied on throughout this migration. First one being modularization. What you see here on the slide is actually the old packaging pipeline we had in Jenkins. It includes multiple steps to build and package CP with four large and complex build stages for Debian, RPM, jar, and archive. Over time, these stages kept growing, adding more steps, and which eventually made the pipelines slower to run. I mean, just to let you know, a Confluent platform isn't just a single monolithic repo. Like I mentioned earlier, it consists of around 35 to 40 different components. We have to pull in code from various Git repositories, build each of the component, giving us jars, and then we finally bundle them into different OS native packages. So what we did here was decompose these massive Jenkins stages into smaller, more manageable and micro build blocks. This allowed us to modularize CP packaging process, making it more efficient and easier to manage. This is how our new CP packaging workflow look like. Although this is just a part of it, a subset of complete workflow. The key difference, it's now modular, as we can see. Instead of having large monolithic stages, we now build each CP component individually within its own semaphore block. Then using dependencies between components, we have structured it as a DAG or pipeline in semaphore terminology. We've leveraged Semaphore CI concepts of blocks, pipelines, and dependencies to achieve all of this. This eliminated the huge monolithic stages we had in Jenkins. Yeah, the next one, it's using semaphore artifacts for caching. As we saw in the last slide, each CP component is built in a semaphore block, and then it's passed on to the next stage as a dependency. So we have to pass on jar to the dependent jar to the next stage. So Semaphore CI provides a built-in support for caching and storing artifacts, and which has made all of this process much more efficient. We are using workflow artifacts to pass not only jars but other build outputs from one block to another within the pipeline. Also, to package CP, like I mentioned, we need to gather all 35 jars into one place, create RPM and Debian repository. So easy and fast way to do this is to use Semaphore artifacts, as it provides fast upload and download speeds, streamlining the entire process. Yep. So the next key design principle is maximizing parallelism. As you see in the screenshot, we have multiple blocks running parallelly wherever there are no dependency or when its dependencies are sorted. So, and within each task, we have jobs that also run parallelly. Each job is running in its own agent, isolated machine with a clean and fresh environment. Yeah, so we have both parallel blocks and parallel jobs. This has helped tremendously overall speedifying the CP packaging process. Another reason we modularized monolith stages in Jenkins into smaller build blocks was to improve debuggability. As you can see in the screenshot, in Jenkins, debugging failures meant scanning through huge pile of logs. Those are in MBs, and just because they were monolith stages, and which was very time consuming. But now, after decomposing and building each CP component in a different block, logs are now separated for each CP component, making it much more easier to identify and troubleshoot build failures. Okay, the next one is dynamic workflows. One of the limitation we encountered during this migration was that semaphore workflows, including different blocks, dependencies, after pipeline jobs and promotions, they are all statically defined in its YAML configuration. This means we couldn't dynamically create blocks and tasks using loops, conditionals, and other programmatic logic. But for our CP releases, we needed workflows to be crafted and triggered dynamically based on given inputs. To solve this, we used Ginger templating, built a wrapper job that creates the semaphore workflow on the fly. This job will first generate the workflow dynamically based on the given release candidates we provide, and then it creates the workflow and triggers it automatically. So as you can see in the screenshot, workflows for package promotion, Docker image promotion, connector promotion, they are all created dynamically, stitched together in one workflow, and based on whatever input parameters we provide. And yeah, and then the release promotion is run. So this makes overall a workflow more flexible and extensible. The next one is use of promotions. The screenshot here shows our release workflow, like I mentioned. Instead of having one large pipeline, we have broken it down into logical promotion pipelines in Semaphore. These pipelines are automatically triggered when the previous pipeline succeeds. So this approach brings in two major benefits. The first one is parallel execution. Since independent pipelines don't have to wait on to each other, they can run in parallel. So it significantly reduces the overall release time. It also gives another benefit of better error handling. I mean, if a failure occurs, we can selectively rerun only the failed promotion pipeline instead of restarting the entire workflow. And as far as I know, Semaphore doesn't support rerunning only failed blocks within a workflow. But with the use of promotions, we have built a targeted retry mechanism, saving us hours when dealing with these sporadic failures. Another key improvement we introduced was defining the pass and fail hooks for each of the block and semaphore workflow. These hooks help us automate failure detection and notification. Here's how we leveraged them. As we see in the screenshot, firstly, it's Slack notifications. When a packaging build fails, an automatic alert is sent to the respective on-call team, ensuring immediate visibility and faster response times. Teams get real-time updates and they can jump into action right away. Secondly, Jira ticket creation. So a Jira ticket is automatically created and assigned in case of build failures. And ticket includes everything: build logs, semaphore workflow details, job links, everything in description, making it easy for engineers to quickly diagnose and fix the issue. This removes manual overhead of tracking failures and speeds up the resolution process. And lastly, we have matrix and dashboard. So to gain deeper insights, pass and fail matrix of each and every block, they are pushed onto matrix system and are being visualized in QuickSight dashboard. This allows us to track trends, analyze failures, and continuously improve our build reliability. Before this, debugging failures was very time consuming. Engineers had to spend at least 30 to 45 minutes scanning through massive logs and just to identify which CP component had failed. Now, with this automated failure tracking, the mean time to detect has dropped from 30 minutes to 0 minutes. This has drastically reduced on call burden and operational overhead for engineers and has improved developer productivity. Yeah, like we saw, and given the complex nature of our packaging and release pipelines, we needed more than a regular CI/CD system. That is a workflow engine that supports manual job triggers and on-demand workflow execution, scheduled workflow execution, then parameterized workflows, and much more. So along the way, we requested a number of features to Semaphore team. Semaphore team was instrumental in supporting our journey by implementing many of them. Like we have built with like the task feature, then we have dynamic job matrix, parameterized promotions, etc. And few of the feature requests, they are still being in progress. They are being worked upon. Okay, enough of talking. Let's see the impact and results. They are pretty exciting. Um, Packaging builds, which were earlier taking 7.5 hours, they now take only 2.5 hours, and which is 70% faster. And yeah, so this is the build time reduction that we've achieved. And also, cherry on the top is that this is achieved by consuming 50% less resources, bringing in significant savings in infrastructure cost. Along with other benefits, of course, that we saw, that the pipeline is more modular, we have better UI, reduced on-call load, etc. But yeah, the build time reduction was the highlight. And here are the stats for our release pipelines. The release time of CP has been cut down from about 35 hours to just 8 hours. And this while shipping 8 different CP patch versions, which is almost 75% faster. Again, it's because there are lots of steps involved in release processes, like running malware scans, promoting OS native packages, Docker images, connectors, then doing a doc release, and so on. So combinedly, it takes around this much time. And all of these have been, parallelized to speed things up. And plus, we did some major code enhancements and optimizations during this migration. Yeah, so that was another big achievement. And this is how our packaging and release workflows have been transformed. Need for speed was the main theme and the driving force behind this migration. Yeah. Virtual high five and a big thank you to the Semaphore team for their incredible collaboration and support throughout this journey. Big thank you. Thanks a lot.